Hi there. In this video, we're going to look at hypothesis testing. And before we do that, I just want to give you a little reminder of inferential statistics. So this was a notes page a little bit ago when we started our statistical inference. So overview of statistical inference. There are two main types: estimation, so confidence intervals, and we've just done a bunch of that, and then statistical significance. That's what we're getting into right now with hypothesis testing. And an example that we did on the first day was the Kiki-Booba test. So I'm going to return to that, and we're going to make it a more formal test. All of these things on this notes page, this overview of statistical inference, still apply. For example, we're going to be looking at proportions, means, difference of two proportions, and difference of two means. So all of this notation, the idea, the parameter, sample statistic, all of that still applies with the same notation. Okay? Okay, so feel free to go back to that page if that's helpful. And now we're going to look specifically at a hypothesis test. Okay, so we did, one of the very first things we did was this Kiki-Booba test. And we did a lot of the steps intuitively just to understand the concept. Now we're going to go back to it and make it into a formal test with the notation. Okay, so I'm going to show you this as an example, but then I'll explain all of it in more detail in a future video, okay? So remember, we had two shapes, a rounded shape and a more pointy, jagged shape, and two words, made-up words, Kiki and Booba. And the question was, and you took a survey of which word did you associate with which shape, okay? So the null hypothesis, and this is what we consider like the standard, the status quo, or no effect. So when we write this out, our null hypothesis is going to be that there's no association between the words and shapes. And another way to say that is it's just a 50-50 guess. Okay, and remember we did coin tosses to simulate this. Okay, and then the alternate hypothesis, that's the thing we're trying to prove, or which we're claiming. We're trying to show evidence of. Okay, so the null, in this case, we're saying there's no association. It's the same as just flipping a coin or 50-50 guess. The alternate hypothesis, that's our claim that there is an association, or the researchers claim who made this up, there is an association between the rounded shape and the word booba. And I just picked one of the associations. I could have picked it a different way. Could have set the pointy one in Kiki or the rounded one in Kiki. So we just had to choose one option. Okay, so another way to say that is it's more likely to match the words and shapes in one way, in this way, than the other way. Okay. Okay, now I'm going to show you the symbols we use. Okay, so we write H naught. It's H with a 0 in the subscript. H null or H naught are other ways to say this. And we're using a P because this is a proportion. We're saying it's a 50-50 guess. That's our null hypothesis. And then the alternate is that it's more than 50% likely that the words and shapes will be associated in one way. And we're saying rounded with booba. Okay, so remember, we're just an overview, so don't worry too much yet. You're going to get exposed to it, and then I'll go over it in more detail. But I think it's helpful to see it in context first. Okay, so then we did this, and we'll do it again. We built a randomization distribution for the null hypothesis in a sample size of n equals 25. Okay, so let's try that again. We use the Rossmann chance applet, and lately we've been using more StatKey, so I'm going to show you with both. You can actually do it with either one. So I'll show you both ways. But first I want to go back to what we did before and show you, and then I have screenshots on the next page for you. Okay, so here is the Rossmann chance one proportion applet. And remember when we did the coins? I'll do the coin toss again. 50-50, we're saying that our baseline assumption is that there's no difference, that people are just randomly choosing a word with a shape, and so it's a 50-50 guess. And then for our number of tosses, we put in 25 because that is simulating one guess for every person in a class. So we're doing sample sizes of n equal 25. Now that you've done sampling distributions and bootstrap distributions, you know that sample size has to be the same every single time. And let's just do one first, just as a reminder. So I'm going to hit Draw Samples. It's going to flip all the coins. So this is, you can think of this as one class result. I'm going to move it up a little bit so you can see the bottom here. Okay, so out of 25, 14 people said one way, got heads. 11 people said the other way, got tails. And I'm going to change my scale to proportion. Should be around 50. It's a little over 50% on this one. But I'm going to do it again. And I'm going to uncheck the animation so it won't take so long, but it'll just show the pennies each time. Okay, in this particular random sample, we had 9 heads and 16 tails. 12 and 13, 10 and 15, 10 and 15, 16 and 9. Okay, and remember we just built up our simulation, and now we've seen these sampling distributions. We're going to call this a randomization distribution, okay? Because what we're going to do is we're assuming that the null hypothesis is true, and that's 50-50. So under this assumption, under this 50-50 assumption, we want to know how likely our observed result is. Okay, so I'm going to go up and make this 2,000. You can make it exactly 2,000, or you can just make it approximately 2,000. And if you want, you can hide the coins if it's distracting. Okay, so remember we had a distribution like this, and now we've seen all of these normal shaped curves, or histograms, or dot plots. And then what we did was we got our sample statistic. Okay, so let me see where... Yeah, so let me go back to the notes for the next part. So we built our randomization distribution. We did it with the Rossmann chance. And then from a previous class, I had mentioned that there was an observed statistic of 18 out of 25. And this is a p-hat because it's a sample proportion. So you could say sample statistic. Often in a test we'll use the phrase observed, the word observed. So observed statistic. So that comes from our sample. And then let me remind you how we got our probability in... We did go ahead and get a probability. So we said we want to count examples as extreme as what we got, which was 18 out of 25, or 0.72. So I'm going to put in 0.72 there, and it counts the number of simulations where that happened. So 43 out of the 2007 that I did had a chance of getting the result that we got, 72% or higher, 0.0214% of the time, okay? And remember, we're talking about how that's really small. So under the null hypothesis, where this is just a 50-50 guess, how likely is it to get 72% to match it one way? And it's very unlikely that this would happen just due to chance. So we say this is evidence for our claim or alternate hypothesis. Okay, so let me go back to the notes here. Back to the notes. I've got written down here this probability that we got. Now, when we did it before, we got 0.026. And I think it was close to that, right? 0.0214 this time. So remember, this will vary. With each simulation. This will vary with, oh sorry, gotta go back to the notes. This will vary with each simulation. So we got 0.026 the previous time. when we first introduced this example, we got 0.0214 this time. Either way, you know, it's 2 to 3%. Pretty unlikely, right? This probability is called a p-value. Okay, so you'll be hearing more about the p-value. Then what I did was I put that graph that we just did on the notes for you. So that was from the first time we did it. So that's also in the previous notes. And we put in, I'll just make some notes on here for you. So this is where we put in our observed statistic. This is our N. This is our P. And then we always do around 2,000 repetitions. And different books say different numbers. We're doing around 2,000. And then here's our observed statistic again. But this time it's on the graph, and it's counting how many samples did we get that were 72% heads or more. Okay, and then this is our p-value, or probability. Okay, and that is also down here, p-value. Okay, great. So let's do a similar thing, but on StatKey. So I want to show you that one as well. Since we've been using that one more lately, you might prefer that, but they're both really good applets. So let me go to StatKey, and let me show you where I am in StatKey. We were just recently in the middle column here for bootstrap confidence intervals. Now we're over in the right column for randomization hypothesis tests. So we'll be using all these almost all. Mean, proportion, difference of means, and difference of proportions. We're not going to test for slope and correlation in this class, but if you take Math or Stat 244, then you'll likely do that in that class. Or if you take another stats class somewhere else. Okay, so we are doing proportions right now. So first it's going to be important to identify which parameter we're doing, right? And is it 1 or 2? So right now we're doing a single proportion, so I'm choosing that one. And here on this one, there are two things we need to edit. We need to put in our null hypothesis, and 50-50 is the default, so we are in luck there. So this is like a coin toss, just 50-50. People are just randomly assigning one word with one shape. And then I'm going to click on Edit Data, because we do have to put in our sample size first. We wouldn't always have to put in our observed statistic in the beginning, but here we do because we need that sample size. So remember, our observed statistic was 18 out of 25. So I'm going to put 18 for the count and 25 for the total. Okay, it shows me this in my original sample to the right here. That's great, and we have the proportion. Okay, so now I'm going to generate 1,000 samples, and I'm going to generate another 1,000 samples. So I have about 2,000. And notice on this one, it says null equals 0.5, 0.5 at the bottom. So that's specifically talking about the null hypothesis. That's saying this is assuming the null hypothesis is true, and we took repeated samples, what results would we be likely to get if the null is true? Okay, so if it's really a 50-50 chance. And then we also saw in the previous, when we were doing confidence intervals, that we could click on this two-tail. Well, now we're going to also use the left and right tail. Okay, so we got, remember, 0.72, and so we're going to the right. So I'm going to click on right tail. And I think I need to move this up just a little bit. When I click on right tail, it automatically goes to this 0.025. So it's still thinking of that middle 95%. Remember how we saw that middle 95%, which leaves 5%, divided between the two tails, it's 2.5% on each side. So that's kind of its general default, is to come up with that. Whether you click on two tail, it does that on both sides. Right tail, it does that on one side, the right side. Left tail, it does that. I've got both tails clicked. I didn't know you could do that. Left tail, then it clicks it on the left side, or shows it on the left side. So I'm going to uncheck left tail and go back to right tail. And I'll explain when you need to know, or how you know it's left tail, right tail, or two tail. But for right now, I want to put my observed statistic in the horizontal axis here. And it says numerical cutoff value. And that's the 0.72, or just 0.72. Hit enter. And then when I do that, it gives me the proportion where that happened in this sample. So it's a little bit different than the Rossmann chance. I like the Rossmann chance because it actually tells us how many samples, then it divides it and it gets this probability. But here, this one just goes right to the probability, which in the long run is just fine. But I like showing you the Rossmann chance because then you can really understand what this one is doing as well. Now, of course, we could calculate it since we know there's 2,000 samples. We could figure out how many little red X's there are in here. Okay, but I'm just going to go with this. This is our p-value of 0.021. Okay, so let's compare that with what we had before. Let me go back to the notes now for a second. So here's the screenshot of that one that we just did. And I'm going to circle a few things. I'm going to circle that we clicked on right tail. But even before that, we had to put our p in for the null, right there, that 0.05. And actually, I'll put a p0 because we're going to learn that that's the null value. And then we had to click on edit data. And in there is where we put our 18 out of 25. Okay, and here we see our 18 out of 25. It came out right here. This is our p hat that we got. Also, I'll write p hat for that as well. What else did we do? So we put our two inputs in there. It showed up in our original sample. Then we generated about 2,000, and we got our p-value. Okay, and we enter. This is the other thing we put in. So we put in our p hat right there. That's our observed statistic. Okay. So when I did a previous simulation right before this to get this screenshot, I got 0.025, and then I got 0.021. And then on the other app, we got 0.026 and 0.214. So you can see it's varying. Again, this varies from simulation to simulation. I think you're expecting that by now. Okay, so what does all this mean? What is our conclusion? Our conclusion, and we'll practice writing out a bunch of these. Our conclusion is it's unlikely to get a sample proportion of 0.72 under the null hypothesis due to random chance. So we reject the null hypothesis. Our conclusion is that we have evidence for the claim that there is a significant association between the word booba and the rounded shape. Okay? So we'll go through some more examples and more details of all that, but I hope this gave you a good overview, and I'll see you in the next video.